Hello everyone, my name is Victor Jaramillo. Today is the 10:30 and this is for the Areno C attempt. So today, as always, we're going to see the data types and the variables and the variables having values. So for example, the data and the clock and the lunch that have 2, 3, and 4. Uses of the LED, of course, the L states equals 0, and then we have the high and low, which is the turn on and turn off. Here, right here, we're gonna use those in the very last piece of the code, but this is for the out. This is for the output of this, as it says right there. It's gonna be for the output, and I'm gonna show you when we go to the Reno. So we're gonna make a for loop for the delay of the delay of one side. Actually, and when we see the Reno, I'm gonna tell you which side is the one that has the time of milliseconds. Like it says right here, the time equals 100, which is the millisecond between between LEDs, between LEDs, and we have the for loop. I needs to be less than 256. Whoops, hang on. Int equals I is 0, and I needs to be less than 256. And then we have the increase, and we must update it every time, and then we output the delay time. Now this part right here, it's a bit confusing. I had struggle with this code to understand this code for a bit. I know there's comments right around there, so they're gonna read this line by line. Digital writes launch low, which is puts the thing on low, which I understand that it was gonna turn off, which it does. Duh. Shifts data clock and miss first in value, which is shifts out the 8-bit of the shift registrations, and then you have the digital write launch high. This, I feel that this command right here, it's for the chip. This part right here is for the chip. As I was read below it, since the LED status set, please, for the love of God, since LED status set in then stands to that 74HC595, as I'm gonna call it a chip. Okay, I'm not gonna say that. I'm not gonna repeat myself with that. I'm gonna call that a chip. Sequence same as update LEDs, except the shift out is done in software. As you can see, what's happening. So we're going to skip this part right here, and we're gonna jump to the Reno. We're gonna change this up. We're gonna go to the Reno. We're just gonna talk about how they turn on. That part of code is exactly what's going to happen. It's gonna happen right here. You see the chip right there, and the cables around our informations. That this side right here, this is where the side of one piece of code, which is the time of the milliseconds ones, as you can see right here, are turning off, turning back off as a millisecond. Now, and when all four of them are turned on, they will send to the other side. They will send it, and when all four are done, they'll reset. That's what the code is trying to say. That it's sending the data to the other side, and when all four of them are they're up, they're all going to reset. But this one just will just keep going. This one, when it has 4 already up, as the loop says, as we're gonna see in a second right now, when all 4 of them are light up, it will reset. So let's see the code. In the bottom, update LED long into value, and the digital writes launch low, which will pulls the chip into low, and then here we have the for loop of the other side. Actually, no, it's actually all 8 all 8 LEDs. My bad. It's all 8 LEDs. And when all 4 LEDs are turned on, all will reset except with one side. I'm saying it like one side will reset, but it's technically both of them will reset. But because we have a code that resets the one side of the LED every millisecond, it won't see like it really reset. It would just see that it would just end it and just start again. That's just the end of it. In vid value B1 billion, which is we use the bit mask to select only the 8th bit in a number. The ones are addressed this time through we through, and then value equals value, and then less has to be less than 1. We move our number up 1 bit value, so next time bit 7 will be bit 8. We will do our math on it, and then we have the if equals 128, the data high. If a bit 8 sets, then set our data pin high, which is for one side, and for the other side we have the digital write clock low, which again is for the other side. And then we have the detail write, detail 1, and then we have the digital write launch high, pulls the launch high description or our data into the beginning display. So going back to the LED, going back to the Reno, we're going to see how you set it up. Right now is in spaghetti mode right now. I've run out of reds, as you can see right here. I run out of reds, so it will just keep going as a spaghetti. So I had to use yellows. They're a lot longer. That's why they're so long. That's why they're kind of long and stuff. So this will get power up to this side, and this orange will power up to the other side. The little blue one you see right there, it's actually connected to the positive, and to the chip, which is the VCC, which is what powers up the chip. And same thing over to the other side. As always, when you have a positive, you must have a negative. So it's over here for the negative right here. Number 12 right here, the little one, is the same thing. So the one up here is the positive. The one below is the negative. The G and D. Okay, so come on. Okay, so 6. No, it's 5, 6, 7, 8, and 9. 5, 6, 7, 8, and 9. Okay, so 5, 6, and 7 are for this was in the back. This was 3 in the back. This 3 in the back. This one. This one forward, the very first one right here, it's actually connected to one all the way over here. This one right here, it just follows this orange one, and it goes all the way over here to number 7. Excuse me, to the number 7 right here. And what it does is that when this one right here is, again, all 4 of them are up, it will send the data, and one of these LEDs will turn on. Now, to pull out the data, there is one from the chip right here, which is number 8. You can't really see it because it's spaghetti again, but right here you can see a little yellow one that's connected to the negative. That's connected to the negative, and this is the part of the outer output emblem. I can see the little chip right here, the output emblem. That's that's what it oh my God. It will output the LEDs in the, so we have the resistors right here. I couldn't find 330s, nor I could find the 550s, so I'm using 220 omega. We have the power cords. So over here, the red one to the 5 volts, the other one to the G and D, and then we have the inputs at the very beginning of the code: the 3, the 4, the 4, the 3, and the 2. And that's the Arduino. Thank you so much for watching, and see you in the next one.